Okay, it's actually September 12th now. I ran into some technical difficulties. For some reason, YouTube and I were not seeing eye to eye yesterday. We just could not get it together to upload your videos. And today, YouTube didn't even show up. Can you believe that? That's like, that's like unheard of. And I called IT and he thought this was an interesting problem, and he did some kind of app where he could plug into he could drive he could see what was going on with my computer, and my goodness, we couldn't figure it out, but now it's working. So that's why I took it. We had a little glitch there. Anyway, let's continue this problem. So this exam, I think we're down to 8. Problem number 8. Okay, so if the puck comes to rest, all right. So you figured out the force, or you know how fast the puck was going from problem number 6, right? So you know how fast the puck was going from problem number 6. Now, when it finally got going. All right, so let me draw the picture of what's going on here. And I'm going to walk you through this so that you can get this. Okay, so the puck we know was going 106 miles per hour. Okay, so we're continuing the notes on this thing. And you converted that to meters per second by doing the good old multiplication by 0.447, which is the 1,609 meters divided by 3,600 seconds, which gives us 1,609 meters per mile divided by the 3,600 seconds per hour. And so the hours cancel and the miles cancel, and we're left with meters per second. So you did that. And so the puck was initially at rest. Okay. Puck was just sitting here at rest. And then bang! We hit it with the stick. All right. And then, so it goes from 0 to where V equals 0 to V equals 106 miles per hour, but we, of course, do it in meters per second. All right? Now, new problem. Now, we know the mass of the puck is 0.17 kilograms. Okay. And so let's start here. What's the next question say? If the puck came to rest, what was the force of friction on the puck? All right, we can do that. Because we know it came to rest in 400 meters. We know the change. Okay, so now here's where we look at that change in kinetic energy again. But we're going to keep everything positive for this class. I mean, if it was my Physics 210 class, I'd be kind of a stickler for, well, is it negative? Okay, so it's losing its kinetic energy, right? So it's got this massive amount. So the kinetic energy 1 is equal to 1/2 mv squared, where v is equal to 106 miles per hour. But of course, we know we're going to convert that to meters per second, right? Okay. And then kinetic energy 2 is 0 when it comes to a stop. All right. So if I take kinetic energy 1, now this is kind of bad, minus kinetic energy 2, that's going to equal the force of what we call kinetic friction, which we'll learn about a little bit later on in the course. Kinetic friction just means it's roll. So like the stapler on its side, that's kinetic friction that's working against it. You know, when I push it, that's the kinetic friction. Or stapler, that's called a tape dispenser, Doc. Okay, times D. So you can figure out this kinetic energy. You know D is equal to 700 meters. So you're going to take the 1/2 mv squared at the 100, convert it to meters per second. Don't forget to square it, divided by the 700. And that should give you the force of kinetic friction. Let's look at problem number 9. How many seconds does it take for the puck to come to a stop? Oh my gosh. Okay. Problem number 9. Here's what we need to do. Okay, so 106 meters per second, or miles per hour. Again, convert that to meters per second. Okay, that's how much it started, and then it stopped. Here's something you don't know. Okay, that the time it takes to stop is equal to the change in velocity, the 106 miles per hour, in meters per second, minus 0, because it came to a stop, divided by the acceleration of the friction caused by the friction. The acceleration, that's the slowing down speed. Oh! 106 miles per hour minus in meters per second minus, it came to a stop, the acceleration due to friction. And then you get the time. What's the acceleration due to friction? We know the force is equal to mass times acceleration. So you take that kinetic frictional force that you got in problem 8 and divide by the mass of the puck. Okay? And you'll get a pretty good, you'll get a frictional force there. Okay? So you take what you got in problem 8 and divide by 0.17, and that'll give you this. And then to find the time, you'll do that. Okay. That's kind of hard. So take your time. Okay, I'm going to stop here and we'll go on and finish the rest of it because I think I go kind of nuts on the rest of it too.